very much for sticking around. Hope you've enjoyed the last 2 days. I'm Viv Richards, and I'm from Wales in the UK. And this session is called Spot the Difference, Automating Visual Regression Testing. So in this session, we're going to look at why manual testing alone often isn't enough. We're going to look at some common issues with end-to-end UI testing. We're going to look at ways to that we can improve on UI end-to-end testing, but also then move on to visual testing, what it is, some common pitfalls. So I will be sharing some code that I've created. There'll be a link at the end which you can sort of download the code. It's on GitHub. This project was really a proof of concept. So we had lots of tests that were taking a long time to run, UI end-to-end tests. So we identified that visual testing may be the way to go. But rather than just buy a tool off the shelf, what we wanted to do was just to prove that it added value before we started then to invest in anything. So why automate end-to-end tests? Well, it can be more reliable because it's scripted. You tell it what to check and it'll run through the steps and it'll check. And it can be as well significantly faster because it's being executed by a tool compared to a manual approach. There are quite a few common sort of issues with automating UI tests. And the first one's quite a big one. And it's not just investment for buying a tool or framework, it's actually getting people on board with the new tool. So, I'm sure everybody's busy trying to, do whatever test they do, manual testing and run various other levels of testing. But for us, for where I currently work, we have to try and get people to move away from just manually testing and try to show them what Visual Studio is, show them what C# code looks like. It's quite a lot to take on board when you're very new to looking at automation. And it's only, automated testing is a practical option only when the test cases are run, quite a few times. If you're just doing something just to, say, dump some data into to get a test ready, so it's a throwaway test, you're probably not going to want to invest a lot of time in creating an automated test script if it's just a throwaway. And whilst it's not really that important for typical sort of end-to-end UI testing, for visual testing, it's really important. So the standard way of testing using Selenium, it doesn't entail human observation. So whilst you can say that elements exist somewhere in the DOM or the document object model, it doesn't actually say whether they're visible to the end user or whether they look as they were intended to. And it can be a slippery slope as well. So I've seen this quite often whereby people, they pick up a new tool and they get quite excited by it. They realize that it's really powerful and they can automate quite a lot of things. And so they do. But then they start building up all this sort of framework and they start automating everything to the point where, like this image shows, I'm not sure if you can see it at the back, but somebody's just asking for salt. And the friend's just saying, hang on, I'll write an automated test for that. And I've seen this happen quite a lot. And this is a really bad thing to do. I see this a lot as well. So this is the inverted testing pyramid. It's called the ice cream cone anti-pattern. And what this is showing is that, so the idea is the lower down the pyramid, the tests are quicker to execute, higher up, slower. Likewise, the lower down the tests they should be cheaper to implement and maintain. And then higher up the pyramid, slower, the more expensive they are to implement and maintain. But you always have as well at the top the manual exploratory testing. So unless you're using some really clever sort of AI sort of testing, I'm guessing you're always going to still want to try and do some manual and exploratory testing anyway. So I've seen in companies the tests that they have very few unit and integration or service tests. And rather than just talk amongst within the teams and say, look, we need to get more unit coverage and integration tests. What the testers then do is, or developers, if they're creating the tests, they just create lots and lots of end-to-end UI tests. And that's not just the happy parts. They'll actually start to do, so if you imagine like a shopping cart, they'll start to do all different sort of logic type tests in the UI tests. And all of a sudden, they're just building up all these tests because they are sort of hitting various levels. It's just the wrong way to go about it because the tests, they're going to be harder to implement and maintain, and they're going to be quite expensive and slow as well to actually give you the feedback. So teams, they we have discussions and we say, well, you know, we need to start pushing the test further down the stack. And I've seen this again, whereby what will happen is the testers will work with developers. And I appreciate perhaps that's probably not a common thing, and we should be doing more of that. So what we do is we have WIP limits. So if you work within an agile team, you have work in progress limits. So if there's 5 people on the team and you've got 10 tickets, you can only have 5 tickets in progress at one time. So what this does, it stops people picking up more than one item, and then it forces people to pair. So whilst developers may not feel that they can test, and testers may not feel that they're comfortable in pairing, both have really good things that they can offer each other. So testers tend to have a lot of business knowledge. So whilst they may not be able to program, they can still pair and add value lower down the stack. So then they start adding lots more unit tests. But the problem is, without adding integration tests, you end up with something like this. So you have a lot of coverage at the unit level, but the units don't work well together when you start then to see how they integrate. And it's fragile testing. We should be trying to push the test as far down the stack as possible, so we're getting quick feedback. I've seen tests that can take up to maybe 4 hours. So we work within 2-week cycles. And by the time we've run all the end-to-end automated tests, the test takes so long that we're not getting the feedback quick enough to be able to react to it. And the whole thing with Agile is failing fast. So by pushing the test further down the stack with the unit integration tests, service tests, you can get the quick feedback. The UI tests should be happy path tests through, and try and just, see if there's somewhere else that you can start to add value and get that feedback. So this is probably what you're probably familiar with. So this is the testing pyramid. It's an adaptation of Martin Fowler's testing pyramid. And what this shows is you have quite a lot of unit tests, then integration service tests, fewer. UI tests, using sparingly, just having like the happy paths, and then you've still got this massive sort of manual and exploratory ticket at the top. So why not just stick with manual testing? Because what manual testing gives us that we don't get with end-to-end UI tests is we have human observation. We can see when things don't look right. But there's a big problem with manual testing, as you probably know, is that it's time intensive. While you're running through scripts, trying to make sure that the software looks and functions as intended, you can't, if you could automate some of these testing tasks, then you could then sort of, use your time wisely. And it's not accurate all the time either, because if you work as part of an agile team, there's the ceremonies every 5 minutes, it feels like. You have your stand-ups, and you have 3 amigos and refinements and retrospectives and reviews. And, devs and testers, both the same. If you get distracted, you can make mistakes. It takes, 15, 20 minutes to try and get back into what you're doing. And so these distractions can cause you to miss and make simple mistakes. And it's only practical as well when you're sort of doing the tasks or running the tests once or twice. If you find yourself running through the same test scripts or the same tasks more than once or twice, you're probably going to want to try and look to see if you can start to automate it to free up some of your time so you can actually test the things that you can't automate. And I see this a lot as well. So in my current company and my previous 2 companies, a lot of investment was made in trying to create a really nice framework. So the idea was that we were trying to help get manual or people who recognized or identified themselves as purely manual testers. We wanted to get them so they could start to write automation themselves. So we spent a lot of time in trying to create helpers and a big framework so they could easily get on board and start to add value and automate a lot of the manual types of tasks. But the problem was that even when we tried to give them the wheels for the cart, they never had time to slow down. So they could never actually use a framework because they were constantly sort of chasing their tails, trying to just run through the manual testing tasks. But the problem is, you can't see the arrows here, sorry. It's a catch-22 because, or the wording actually. So they could never automate because they didn't have time, and they never had time because they didn't automate. So they were just stuck in this constant cycle whereby they never could stop to try and automate stuff to actually give themselves a chance. So it's about breaking the cycle and trying to work, not just relying on just the testers to try and implement these tests. We're all a team and we're all trying to, deliver a quality product. We need to work smarter as a team. Don't be afraid to ask for help if you're new to automation. Developers, they're highly skilled in writing code, so work with them and try and get help. Cookies work wonders as well, so take a tray of cookies or something and try and get some help off them. But it can be quite sort of daunting. So when you start to try and move away from purely manual testing, there's just so many options out there, and it can be difficult to sort of pick, one over the other. And as you probably know, if you type in end-to-end UI testing, the thing that pops up quite often is Selenium. But it really depends on sort of lots of different factors, and you really need to try and have a spike to try and weigh up what works for you. Don't just pick something because someone else is using it, because every type of product is different. So Visual Studio Coded UI. This is really cool if you don't really want to write any code. So it's got like a nice little GUI where you can just click record, run through the website, record some steps. It only plays back to an IE. So depending on what your customers use, or depending on your browser support policy, it may not be right for you. Some of them, like Slendroid, if you're trying to obviously target a specific type of operating, like Android. Some of them are free. Well, most of them are free. So we've got some of them are JavaScript. Some of them may work with C#. Selenium, again, it supports a range of different languages. And Appium's quite an interesting one. So what some of these things allow you to do in Selenium, you can write your tests in Selenium, and then you can install Appium, which is free, and then all of a sudden you can extend the driver support for your tests and target like Android and iOS devices. So you can really extend it and start to extend your support for different devices. It's really powerful. So I'm not sure if it's just a Wales thing, but most companies or most job adverts, it's just Selenium. And the reason that we chose it was because it's open source. And that's really good because we can see actually what's going on. We can get support from the community because it's a well-known tool and it's well used. Can operate in almost any operating system. Really good language support. So our developers were using C#, .NET, MVC, and we could use .NET. And like I've touched on, the browser support is really good. So even if Selenium out of the box doesn't support the drivers, you can extend Selenium to then support other browsers as well. And for our customers, we've got to support Chrome, IE, and Firefox. That was really important for us. But it's not a silver bullet. And I think you should be using it just to try and test the happy paths. Don't just automate everything because you can, because what you'll find is you're just building up all this sort of technical debt, and you're just going to get a lot of tests that are hard to maintain, and they're going to be quite costly. There's a lot of issues as well. So if you're using Selenium, speed to execute tests. Some of these tests can be quite slow, depending on, so some browsers execute a lot quicker than others. And this is tricky when you have to support more than one browser. So for us, when we support Chrome, Firefox, and IE, all of a sudden we have to start adding, if this browser then because the selectors, they may render quickly on one browser, but not on another. So you have to start slowing your tests down. And whilst it doesn't matter for most UI end-to-end testing, when you look at visual testing, the browsers render differently as well. So all of a sudden, you have to take that into consideration. Execution speed. So again, like I mentioned, the tests can be slow. So for us, we have our customer, which we call an agent, and we have their customer, which is a client. So our customers are banks, and they share with the client screens. And our tests can be quite slow because before we can run our tests, the agent has to log in, generate the code, the client logs in using that code, and then they start through the journey. So it can be really slow. Some of our tests individually take up to 15 minutes, and then when you put them within the suite of all the other tests, come regression day every 2 weeks. It takes up to 4 hours, and it's just not quick enough to give you the feedback. Like I mentioned, maintainability. So when you start adding weights for things, and when you start looking at the way in which you interact with elements based on the driver type. So in Chrome, you may be able to say driver find element by ID.click. In IE, you may have to do a .send keys enter. So you have to start then, based on the driver type, interacting differently, and all of a sudden, for one or two little actions, your code starts to grow because you're trying to take account of all these different driver types that you have to support. So I want to ask, how valuable are these tests? So apart from end-to-end testing, so if you had to just get onto this page and check out, write these tests, how valuable are they? What they're actually doing is C# code that is just finding the H1 element, checking the text, and we've got a few different checks. All it's doing is checking the text. And for us, we're not doing localization testing for this mock-up. This isn't our actual page, but if you were doing localization testing, perhaps it's adding some value. But if you're just checking text, you've got 6 lines of code here, which if one element changes, you can have a failing test, and it's only saying that the text exists somewhere within the DOM. It's not actually saying about the colors, font sizes. So how much value is that actually adding? Late one Friday, we had a call to support, and the client was unable to use the end application. So the agent gave us a call and said, can you check out what's happened with your tests? We checked the tests, and they were all passing. And we thought, that's a bit strange. Loaded up the web application. And what had actually happened was that there'd been a CSS change, which had then hidden the element behind another element. So the tests were rightly passing because they could find the element within the DOM, which is what the Selenium end-to-end UI tests do. But the form wasn't usable. The client couldn't actually complete the transaction. So very quickly, there's quite a few things you can do as well. So when you start to look at writing maintainable, or if you're new to end-to-end testing, there's a few different techniques that you can do. So page object patterns, Martin Fowler has a really good blog post on it. But basically, related to the screen I just showed where we were checking the text, if you imagine you had lots of tests whereby you were checking, referencing lots of different elements in your page, if the element ID changes, for instance, all of a sudden you have to update all these tests everywhere where you interacted with that element. By extracting out how you interact with that element to a page helper object, if you had 5 tests then interacting with that element that you've extracted, you just update the page helper object and all the tests would pass. So it's about sort of extracting out the interactions so you can then manage the test better. And QA selectors, so you may know them as data selectors. So this is really cool. What you can do is, so the top screen shows the markup for this form. But what you can do is, within the class or the data attribute, it doesn't really matter, you can say QA or data, if you like, hyphen the element type, so button, hyphen, and then the value of the button. So you'd have QA hyphen button hyphen cancel, QA hyphen button hyphen submit. This is really good because all of a sudden what you do is, your tests are going to be cleaner because you're always writing driver.findElement by CSS selector or class. So you don't have to worry about, am I finding it by ID, class, CSS selector? Because for some reason, developers and testers don't talk on teams. And it's very odd. So when it comes to the front end being developed, the tester will then go to write the tests, and all of a sudden they're trying to find an element whereby it shares the same class name as another element. So it can be quite tricky, but using this technique, you're always finding the element by the CSS class. And also, if a front-end developer comes to make a change, they can see there's a QA tag, so they're less likely to make a breaking change. So it works quite well. So I wanted to ask, how good are you at spot the difference? So on the left-hand side, there'll be one image. On the right, the same with some differences. Let's see how many you can find. Okay. I appreciate that was probably really difficult from the back. I set up the slides myself, honestly, and I struggled. Okay, so could you put your hand up if you found 1 or 2? Can you keep your hand up if you found 3 or 4? 5 or 6? Any hands? Sorry, I can't see. No? Okay. So there were 9.
Whoa.
Yeah. So we'll walk quickly through them. Yep. Oh, I haven't highlighted. Right, for some reason the circles have gone, so I'll try and find them. Okay, here we go. So it's really difficult from here to see, but the Selenium icon, there's a little blue line missing. Well, there's not one there, there's one there. So that would never be picked up using Selenium end-to-end tests. There's padding. There's a little aerial missing off this image that won't get picked up. We've got padding here. Text at the end, 18, 17. So there's a number of different things. Yeah, buy tickets, yeah. So there's quite a few different things there. I'll never find them all. I can send the slides out with the circles, honestly. So there were 2 image changes. Luckily, I wrote that bit down. 4 text changes. So the text changes, we would have found 4 of the 9 differences in this instance. We never would have picked up the image differences, and we wouldn't have picked up the 3 style differences. And the problem is, we only had 30 seconds then, and it was quite tough to try and find more than 5 or 6. And, you know, how do you know when to stop? So what we are moving on to, I promise, is how can we start to add then more value to the top of the pyramid? How can we start to automate a lot of the things that we typically do manually? So combining UI with manual testing. So what if we could say then, we've got this base image. So this is how the website currently looks. And what we want to do is, we're going to piggyback off our Selenium end-to-end tests. So we're going to navigate to the web page, take a snapshot, and say, does the web page, as it currently looks, match our base image that we expect? So again, when you start to look at visual testing, there's many, many options out there. And it really depends, again, on what languages are you comfortable with. If you're already using Selenium or some sort of framework or tool for end-to-end testing, you're probably going to want to pick a visual testing tool unless it's got a nice GUI that sort of ties in with that. Because if you're expecting the testers to get on board with a new tool, you want it to be as easy as possible. So you're probably going to want it to not be a steep learning curve. Some of these are free, some of them are not. Wrath is a really good one. It's by the BBC. Lots of them do the same things, but in a slightly different way. Some of them are more updated more often than others. So you need to weigh it up really and sort of do a few spikes to see what works for you, because there's not a one-size-fits-all with this. Apply tools, I'm sure you've seen them upstairs. This is a pretty cool tool. So when I set out in creating this framework, which I'll share, it's not complete, like I mentioned at the beginning. You can try it, and it's more to prove whether or not there's value in visual testing for yourselves. And then you can say to your business, look, we want to buy Apply tools. And it makes it a bit easier to have that discussion. What Apply tools do, which are really cool, I'm sure they've told you all about it, is they do things like, because they use AI, you can actually say, this is my Twitter feed. You can have the same 4 tweets, but in a slightly different order, and it can tell you that it's actually the same content. So you can do things like that. It's got a nice GUI where you can drag over. They announced, I think it was this week on Tuesday, that they've now got integrations for Storybook and Cypress.io. Cypress.io is a really cool thing for, it's non-Selenium, it's on client side for writing your tests. It gets around things like, wait issues, waiting for pages to load and that type of thing. But what it doesn't support is IE, which probably isn't a bad thing, but if your customers use IE, then you have to support it. So the issues with other offerings for us were that they didn't work straight out of the box. There was a steep learning curve. We're already trying to get people on board with moving from manual to also doing automation end-to-end testing. Small community or lack of support for some of these tools. Some of them are quite new. They needed to tie into our existing framework, which is C#, MVC.NET. And cost was a massive thing for us because, as any of you know, if you go to business and say, look, we want to buy this tool, they say, well, give a business case. So what we've had to try and do is actually create our own thing to prove this value before we can then look to purchase something. So there's been quite a few issues. Probably the biggest issue has been that it's only been myself working on the framework because we've all been trying to get through manual testing and other tasks. And a lot of the challenges, to be fair, both in visual testing and end-to-end UI testing, has probably been because of us, because of the way we've developed our products. So for instance, like I mentioned, developers and testers for some reason don't tend to talk to each other. Very strange. And so what we have are pages whereby we reuse the same class names or IDs are generated. So all of a sudden when you're trying to find elements, it just becomes quite difficult. When you start to look at visual testing, this is a Google Chrome driver taking a snapshot of the Google homepage. And what this is showing is that the pink boxes are all the places where a Firefox driver thought there was a difference in the same page. So driver types, they render slightly differently and they add padding. So this is something you have to be aware of. Execution speed. So what this is showing is we had a base image for Google. We said, go off to the Google homepage, take a snapshot, compare it, and in 4 seconds, we were able to say, the page looks exactly how we expect. There's 4 lines of code. We haven't just checked a line of text. We've got padding, colors, images, everything. It's just really powerful. But even though that was really quick, and it's 4 seconds, be aware that if you start to implement something like this in your tests, we're just piggybacking off Selenium. So we've still got all the setup of logging in as our agent, generating the code, logging in as the client. So we've still got to get to the point where we can actually then take the snapshots to do the comparison. There was a really good talk. I forgot the lady's name and the name of the talk. Perhaps I'll tweet, sorry. But she gave a talk on how you can basically skip like the login part. You can automate that, and then you can do the UI test. Jane, thank you. So yeah, it's fantastic. So if you start leveraging some of that, then all of a sudden it will speed up your test, and something I'm actually going to look at. It's really good. Right, so we're going to play another game. So this is human versus machine. I wanted to prove to the business that this can be a really quick thing. So what we're going to see is an image with no Wally, or Waldo maybe, some of you know it as, and an image on the right with where's Wally hiding.
Oh my goodness.
And these are the 2 exact images that we gave the machine as well. So I'll zoom in a little bit, because I appreciate it's quite difficult. I'll zoom in just for the back as well, because it's difficult from here to see. Has anybody found him? Yeah, so he was hiding up in the corner. So this is the thing, we've got a lot of different things going on in your application, your testing. Sometimes it's very difficult to see. With visual testing, 293 milliseconds. We passed 2 images and said, look, let's give us the difference. And what it's done is it's drawn pink boxes around Wally. So when the tests fail, what it'll actually do is it will actually create a difference image, and it'll draw the pink boxes as well, so you can actually see where the change happened. So this was the form again, the old code. Using, most of the frameworks are very similar in implementation. So you just specify the image or base image, the URL to go to, and then you say, I assert no difference. You can take it further. So if you use SpecFlow, which is a .NET port of Cucumber, what you can do is you can create scenarios, and you can pass in the home page and the base image. So you can create many scenarios. And then within the step file, all you're going to have are the 2 steps, regardless of how many scenarios you have. So the maintainability of your tests, it's hardly anything, and yet you're able to check for everything on all the pages you pass to it. So it's really powerful. You could take it even further again. I haven't got a slide for this, but instead of using many scenarios, you could have 1 scenario, and then there's something called a scenario context, where you'd list a table of each base image and URL, and it will actually spit out then all the results. So you wouldn't have to have 100 scenarios, for instance. You just have a table with 100 scenarios, and it's a lot easier to maintain. So, as I mentioned, you can easily identify the differences. So it does depend on the tool you use. For our tool, this is what you get. The left-hand side draws the boxes for where the differences are. The right-hand side, what this is actually showing is, I will touch on it on a later slide, but it's showing the amount of tolerance required for this image to pass, because what you'll find is that hardware differs on machines, and so you will get some things that will fail, even though to the human eye they look very similar. It can be pixel perfect. I believe Applitools is. They use AI again. What this is byte for byte comparison. So again, it can be one pixel perfect, but as soon as you start to use it on lots of different machines, even if you believe it's the exact same hardware, you will find that you'll start getting issues and you'll have to start setting a tolerance. There are ways around that, which I'll discuss in a second. Image quality difference. So there is no difference really, because as long as you're using the same machine and the same driver types, it's regardless of what type of device, it'll be the same difference. There's been a lot of challenges so far. So maintaining base images, initially we thought what we could do is, like the first slide I showed with the Google homepage, we thought we could just take one base image and then run it against many different browser types. You can't. So what you have to do is, for each of the browsers that you want to support, you have to then start to maintain a base image. So you can see quite quickly how if all of a sudden you start to support lots of different browsers, it could become a maintenance headache, depending on how far you want to take it. Screenshots, so again, many of the frameworks do this. So as a W3C standard, when you take a snapshot with a driver, what you'll actually get is what's in viewport. What we've done with this framework, we've been able to work out the height and width. So we inject into the driver some JavaScript, work out the height and width, and then we basically inject JavaScript to scroll, stitch the images. But something that's really cool as well is you can get down to element level. So if you deal with banks and things like that, and they have specific sort of branding, you can actually get down and say, well, I want to check all the buttons are styled correctly. I want to check all the headers. So you can get to that level. You don't have to take full page comparisons. So this caught me out. What you can do is, if you take screenshots to do comparisons, don't maximize the window, the driver type, the driver window, because what will happen is, depending on the machine that you open the window on, obviously it's going to take a snapshot and the height and width are going to be different. So just set height and width of the driver, don't maximize it. Responsive design, so if you care about responsive design, you can set up profiles and you can just open the driver in different height and widths and take base images. Like I touched on, hardware issues. So again, what you'll end up with is, you'll have, if you create base images and run them on someone else's machine, you'll find they'll fail, even though to the eye they look as if there's nothing wrong. And it's because of anti-aliasing. You'll see some of the, this is really difficult to see by eye, but it'll fail because you'll think that your machine is slightly different. So you can get it to output a difference image. There's an option there. And what you'd do is you'd find the highest number, which is 21, and you set a tolerance within the frameworks where you say get difference and you pass in the base image. And there's an optional parameter where you pass in the tolerance. So it'll still pick up text changes, it's just it's not pixel perfect. So there are ways around it. It depends on how important visual testing is, I guess, to your sort of testing strategy. Storage. So when you're starting to support lots of different driver types and responsive design, quite quickly it's going to get out of hand. And you're trying to automate things to give yourself more time, but what you're going to end up with is instead, you're going to be maintaining lots of base images and lots of difference images. So you want to be mindful of what you're trying to cover and just be aware of that. I know, again, some of the other tools, I keep mentioning Applitools, I don't work for them, I promise. Applitools allow you to group them and do like group reviewings and things like that and approval. So it's really powerful. Dynamic content. So this is really interesting. So it probably wouldn't work if you were using visual testing on something like WordPress or Drupal, where they're quite sort of data-driven. But what you can do is, if you imagine we've got this WhatsApp meetup page, and we expect this bit to sort of change a lot, so where the attendees book in. What we've created and what the other frameworks do in a slightly different way is, again, we inject. So we get this element by ID or class, work out its top and its left, work out the element's height and width, and we just blanket over the element. Then we take the snapshot. So what that allows us to do is every time we then go to that page, the dynamic bit is covered, so it doesn't matter. But again, because you can take snapshots of individual elements, you can either do it that way or you can just cover dynamic bits. It can be quite powerful. If you deal with websites that have got moving elements, again, through the driver, we've created helpers so we can inject JavaScript, and we just stop all CSS3 animations or find videos and just stop, just using pure JavaScript. This is something that's really powerful, and I don't think a lot of the other visual tools even talk about. So what you can do is, we use a third party called Aspos. Other tools are available, it's quite expensive. But what you can do is you can feed in PDF documents, export the whole document or individual pages as images. So all of a sudden, you can then check through the image comparison a 16-page document in under a second. So when you're dealing with lots of customers in different languages, it's very easy to miss, as we saw with padding or subtle sort of character differences. It's very easy to gloss over them and miss them. But with this, all of a sudden, we can say, for all of our customers, when they get to the end of a journey and they sign the document and download it, we can quickly check if the document looks as expected. So it's a really powerful thing that you can do. Dynamic content. So again, what you can do is you can use regex. So it depends on the third-party PDF provider you're using. But you can use regex to look within the PDF, and you can sort of find the date, for example, and you can overwrite it to a known date. So every time you take the base image and then do a comparison, you know the date stamped, for argument's sake, when you sign the document, it's going to be what you expect. So you can deal with that, and you can sort of fudge the data, if you like. Upcoming challenges. So I forgot to move this slide, to be honest, but what we were going to look at was how we could just compare text, or how we could just look at layouts instead. Hopefully, we'll be moving, now that we've proved it adds value, to something that's sort of further developed. But these are things that, perhaps you'd want to consider. You can do the text only already by looking through the document object model. Layout only, you could perhaps inject some styles or something like that. So just because you've seen this, hopefully you won't just go off and use it because you can. It may not work for you. It really depends on the type of application that you're building. So by all means, try it, but don't just use it because you can, because what will end up happening is that all of a sudden you may end up with another framework to maintain, lots of base images, and I think people already automate too much just because they can, so just be a bit mindful of it. This is the GitHub repository. It's very rough and ready. There's some C# code there that you can try. What I've also created is a NuGet package. So if you type in that command, it will, to a brand new project, it will install Selenium WebDriver, Chrome driver, and lots of example tests. So within probably a minute, you can actually start, for all the examples I've given, you can see how they work and you get a feel for it. Feel free to use it however you want, but it's very rough and ready. So if you do like visual testing and it does start to add some value, you'll probably want to look at one of the other sort of providers. That's it. Thank you very much.